Hey,
Hello, how are you?
I'm doing well. How are you?
Pretty good.
I know Danny cannot make it because they're presenting at a conference. I forget what conference, but philosophy, psychology related,
Right.
on affordances.
Oh, good.
Oh, the other people from Western said that they just have too much on their plate, which I understand because they're
Yeah.
still
Oh, yeah.
students. One of them's like starting a PhD program, I'm
Wow.
pretty sure. So
Pretty good.
that's fine. Um, they expressed remorse. They were looking forward to reading the book.
Yeah. So we're on chapter 3.
Yes.
Okay.
Page 60.
Hello.
Hello.
What?
I have no idea what was going on. I'm like, oh, it's starting at 7:30. Oh. Sorry. I'll get this right over here. How's everyone this evening?
Pretty good.
Pretty good. It's not super hot here, which is nice. It's been in like the 80s, and I don't have AC, and that's been just like tiring. Like I don't want to move enough that I like break more of a sweat that I'm already sweating. And the sun, it's the solstice, so the sun has been just like beating down. But today it was nice and cloudy, rained a little bit.
It's been particularly cool here in the sense of it's not even that as on the verge of going outside and like it starts at like page 80 something, right?
Page 60, I think.
Yeah, we didn't finish chapter 3. You wrote down page 60.
Let's start there then. All right, I'll get that set up and we can go super live. All right, super live time. Yeah.
Live streaming is on.
Okay. And here we go.
All right.
So we were at what page? 60 something?
60.
Okay. So I mean, I don't know if you have any general updates. We mostly talked yesterday a little bit. It looks like we were kind of last time like this talked about ants, E.O. Wilson, embodiment, analogy creep. I remember last time Bradley had something in the chat that was like the human use of like loose analogies or something.
Oh, yeah. That was in the Slack channel.
Question about that. Start on page 60. Good job. Next week. Topics of digital analogs, theory of learning, Block versus Pavlov, blood versus synapse. Interesting quote about theory of learning, whatever that will be reasonable for the machine. It will also be so that the present stage of our knowledge and any theory of learning which I may offer will be premature. So he's kind of trying to play the middle road there. And then I guess we talked a little bit about fractal attendant resonance stuff. And I know that's come up a few times over the course of the last, I don't know, 2 weeks. But I'm curious. I don't know if we want to say anything about these or just kind of go back to the book and start going from there.
That list of things is at least some of it is to come if we start on page 60.
Okay. Get a one-horse Shay.
Yeah.
I always loved kind of seeing. Norbert has a little bit of humor to him,
Yeah.
right? But like, obviously his humor is a century old,
Yeah.
so it doesn't really hit all the time. And I think that's kind of part of the fun of it all in general. Like probably everybody knew, or late more people knew one hot shade back in the day. Now it's like, what is that really?
So what was the point, Locke versus Pavlov? Did we get to that, or are we getting to that?
Good question. I don't know. I don't remember. I know there was some term of Pavlov was mentioned. These indicators are given respectively by the Lockean theory of association and Pavlov's theory of conditional reflex. So something about learning. Oh, this is a little bit further down, I guess. So maybe we're not quite there yet. Yeah. So okay, we'll be there in a few pages apparently.
Okay.
Page 60. One horse Shay. Folks in the dashboard. I don't quite remember what.
Can you go to the top of 61?
Oh yeah, let's do that. Entropic tendency for the more probable or one the less probable. A repeated feedback is a method controlling system by reinserting into it the results of the past performance. Okay.
So I think the one Hosche was wasn't it that like each component like degraded at exactly the same rate? So there's like this optimal aspect to it. I thought it was at the top of 61. Maybe it was at the top of 60 where he says this. Okay, in the middle. Yeah, it represents the pinnacle of engineering because there's like nothing wasted.
Yeah. So he's saying that there's sort of no wasted engineering or tailoring effort.
But contrasts that with how the phone service works, which is like not very individualized. That was his discussion of how he like always talks to this one guy and not so much to these other guys, but the method of reaching them is the same. So there's an inefficiency. Right. So to be able to like respond to that kind of environment and become efficient and like to for your functions to become more specific, like a certain kind of adaptation is needed. So he's setting up learning and feedback here, because it's the tendency of the organism to not be wasteful in this way, even if it's imperfect.
I wonder what the free energy people would say about this. Yeah, and he's kind of like saying like he's kind of likening this to a general. This is sort of how learning works. And the aircraft stuff, and how the plane has limited actual range of motion it can take. It's not just totally random, it's specific. You know, it's not going to do an immediate reversal of course.
So this whole thing is him going through like a control problem here. So why don't
Yeah.
we start with like this passage and kind of walk through, like I guess he's talking about an airplane here. Can we walk through like how he's kind of putting this together? I just want to get a sense of like,
Yeah, I guess I've seen, I kind of heard, like this is like my go-to example of like Norbert Wiener and um, cybernetics. But he starts by saying, there's kind of it, it's kind of him sussing out like probability and relative, like how much can we try to deduce from this, and saying that the plane can't just take a perfectly arbitrary evasive act. It can't just make any choice of action out of all possible actions. There's a limit to it. And um, he's limited by these forces that at play, like centrifugal force. And there's limited by like what the plane can do. The regulators are not absolute, but they're rather statistical preferences which appear most of the time. Um, and then be different for different aviators, and they will certainly be different for different planes. Like what a plane can comfortably do in those situations. Is it more nimble or is it less nimble? Stuff like that.
so he's saying that like there's variability across people and planes that could be inefficient, but you want to have that summary description, so you have to tolerate these sort of statistical regularities as your way to understand the output of the system.
Yeah, there's variability, but there's also a limit. I think is kind of the thing. And I guess what he's getting to this part is saying, um, there has to be the figuring must be built into the gun itself, because it has to sort of account for, there has to be sort of a range of possibility that the figuring is accounting for in that, I don't want to say moment, but in that process, like it feels weird, just I'm so much in like edge computing, but like there must be a certain amount of stuff into this part of it itself that's interpreting the possibility space. This theory must include data which depend on our past statistical experiences of airplanes of a given type under varying flight conditions. So it's sort of like taking into this model of how things work, I guess. Then we can do these actual deductions and calculations.
Yeah.
Right, and then a good anti-aircraft system gun here observes by itself the statistics concerning the motion of the target plane. So like that's the goal, is like less pre-programming and having a device that can abstract from the data in a sense and internalize this like next level of behavior.
I'm thinking a little bit about the big regulators. Yeah.
Oh
What
yeah,
about
definitely.
Where's that?
I don't see it listed, but I just see him kind of like potentially alluding to it. Like
Oh yeah.
you could, the better you can have the model of what the thing can do, the more you can effectively address it.
So basically, this is like a Bayesian model almost. I mean, he's not calling it that, but that's basically what he's getting at. I mean, it seems like it, anyways.
It seems like it, or at least that is one version of this.
Yeah.
So I guess we're getting finally to Locker Pavlov, but he kind of sets this up and says, I guess he's using the anti-aircraft stuff as sort of, or speculating what hasn't been done yet, where it could go, the, getting all this up to a place where getting general feedback affecting the whole method of behavior instrument. This advanced process of behavior learning, which I've discussed, is still limited by the mechanical conditions, etc. But we can infer different ways in which learning of a complex, mechanized. And now I get to these indicators are given by respectively by Levine theory of association by Pavlov's conditional reflex. Before I take these up proper, I wish to make some general remarks to cover in advance certain criticisms of the suggestion that I shall present. So I guess this is probably where we were about to hit from last time. I don't know if you wanted to say anything from these other notes that you have here, Amanda, or just want to keep going with where we are.
I guess that was just a summary of what I wanted to talk about, looking at the quotes that I pulled last time.
Okay.
I think we have already covered the general idea of like learning requiring feedback, and a particular kind of feedback as illustrated by this airplane example. And I think here talking about the synapses is where he starts to get into the digital or all or none messaging versus analog messaging. I think it's not until the end that he says the stuff about how blood contents would be a better messaging system than neuronal firing in some cases, but I found that really interesting.
What if you put that in terms of like the medium, or like the medium's capacity for information and context, or why? I'm curious what you mean by that.
It had to do with this "to whom it may concern" messages idea.
Oh.
So like a signal, like an alarm is emitted, and it gets the attention of, it can get the attention of anyone, but it's really trying to get the attention of a particular thing. And so this "to whom it may concern" kind of message is a general message that affects like much of the system, but it's only relevant to part of the system. But there's something more efficient about that kind of message. I forget exactly his argument for that, but then he uses the example of like blood contents as being able to deliver a message to the brain in a different way than just neuronal firing. And it might be more efficient depending on what you're talking about.
Let me see if I found up there. Yeah, okay. I'll just move on. All right.
Basically, like neurotransmitters versus peptides. So peptides are kind of like blood in the sense that they get released in a wider range of, although maybe he's just talking about a general, like kind of like in cell signaling where it's like a radius around the individual, but basically it's not viewed like peptidergic signaling is not as efficient as synaptic neurotransmitter signaling, but it's still effective enough. And so I guess in some cases it's better, depending on what you want to, I mean, and depending on how you formulate the specific problem. So, I mean, yeah, I guess he uses blood, but you can use other types of metaphors, I guess.
So he's saying the brain could, in theory, be described as something that operates on this all or none principle. Like a neuron is either firing or it's not. So, and there are advantages to that. in particular, the sharpness of the distinction between yes and no. And then he contrasts that with, I liked how he said analogy machines, not like analog computers, but analogy.
Where does he say analogy machines?
Here.
Yes or no, other computing and control machines that you measure rather than count. So counting would be like a discrete mechanism. And then measuring would be like I don't know if he's contrasting continuous and discrete here, or is he contrasting? Because
right.
Counts are discrete, and then measures are sort of.
Is he trying to do digital versus analog? But I'm not sure he is.
No,
he does mention digital, but like yes and no. But I'm not sure it's.
Well, he says, yeah, slide roll versus like a button press, which I guess a slide roll would be continuous, but it has like measurements that are discrete, like the measurement units. So you can't just say it's like, the number has to be rounded at some point, I guess. So it's not completely discrete, but it's also not completely analog.
Right, like maybe the output can be read, it can like turn into a discrete value, but the way the ruler works is analog.
Yeah.
So what is he saying about this? Add this to the prejudices of the physiologists in favor of all or none action, and we see why the greater part of the work which has been done on the mechanical simulacra of the brain has been on machines which are more or less digital basis. However, if we insist too strong on the brain as a glorified digital machine, we'll have to use some of this in the other paper. Will be subjected to some very just criticism coming up from the part of physiologists and from the somewhat opposite camp of the psychologists who prefer not to make use of the machine comparison. Some of them. And instead that in a digital machine there is a taping. I think this is not tapping, but taping.
Yeah, like a computer that just manipulates a like one-dimensional string of zeros and ones. It has the tape that it will print on.
Which determines the sequence of operations to be performed and change in taping in the basic process. The clearest analogy to taping in the brain is the termination of synaptic thresholds of precise combinations of incoming neurons which will fire outgoing neurons effectively. We already have seen that these thresholds are variable temperature and reasonably viable with the chemistry of the blood and other phenomenon on nature.
So do you know why he's interested in the tape? Why does he mention tape?
Well, so the taping is supposed to correspond to, maybe I was inaccurate before. The taping here is what gives the rules to the computer. And so that's supposed to be analogous to like the synaptic weights. Like there is a level of operation that might be completely digital, but there's still this place for variation that I think he's going to end up saying is not best thought of as digital.
Yeah, well, yeah. So, and we'll talk about this more Saturday. So a Turing test is really about like, or at least Turing's method of computation relies on a tape. So if you read about it, you're running a tape through a machine, and there's this thing called the halting problem where it stops at a certain place, and you're able to predict where it stops. I mean, this is all ancient analogy for computing. Like, and I say ancient, I mean like 100 years ago, how computers used to work. Maybe 50 to 100 years ago, I guess. And so that's, I think that maybe why he's talking about tape as well. It's just like, you have this discrete process that we have to, first of all, we can't necessarily use a continuous process for computation because we're interested in sort of the way that a program runs on a computer, which is this analogous to the halting problem. So you can easily make an analogy to that. But then, we don't really have, at least at the time, but we had continuous computers. They had mechanical computers before we adopted digital computers. And so a lot of, I think, what sort of like Turing's work on computability, that was not, I don't know if it was exclusively for digital computing. It's kind of taken, like, it's kind of been applied exclusively to digital computing. But I wonder if there isn't like because this is an important factor for like quantum computing, which is not digital computing actually. It's something else. It's not really continuous computing either. It's like you're running a bunch of programs and they either like solve the problem or not. You have to, depending on their measuring their state. But it's a different paradigm is the point. And so it's just kind of interesting from that perspective. Also because we're going to talk Saturday about physical computation as opposed to like the computation of this. You have the Church-Turing thesis in physical, or in sort of discrete computation, but in physical computation, which is where you have, it's like physical systems that aren't computers. We'll have to get into the description of that. There's a different thesis that is sort of a take from the Church-Turing thesis, but it's a little bit different. So there are different considerations when you think about how a computer is built. Think about like, what are we actually doing in the computer? So when people say computation, they usually mean something to do with like the Church-Turing thesis or maybe something related to that. But maybe there are other forms of computation that exist in the universe, or even that we could invent, that aren't at all related to that. And so I just bring that up because we're going to have this conversation Saturday, but also that he's kind of getting to some of these metaphors that he's talking about from biology. Which ones are the most useful? Maybe there's some analogies from like different physiological systems that are better, say, than like a neuronal analogy for other types of computing. So, and even like, in terms of like neuronal systems, like I mentioned before, you have different types of signaling in the brain. So it's not just like, we use action potentials as like a primary signal, but there are other things going on in the brain as well. And so it's, well, I don't know. I don't have a conclusion here on this, but I'm just something to think about. Yeah.
Important context that I hadn't fully thought about. So he's walking the middle path between the criticisms of, he's kind of leaving the door open for some stuff, like Bradley kind of mentioned and things here. He wants to give a method of constructive learning machines, which will not only enable to build certain special machines, but will give a general engineering. But only if he reaches the degree of generality will they defend himself from criticism that the mechanical process, which he claims is similar to learning, is in fact something of a different nature from learning. And on the other hand, he's describing these. He wants to describe stuff that's not too foreign from the actual observables of the nervous system and human animal conduct. And I kind of interpret this as saying he doesn't want to, he's trying not to go too far out into, he's trying to speak in ways that are relative, like, that have a basis of comparison. He doesn't want to go too far in the deep waters. Um, I don't know. I'm not quite sure what to make of that.
He wants the AI to be interpretable.
Yeah. Back to Locke we go. With Locke's tabula rasa.
So wait a minute, let's go back through that too, because we talked about Locke versus Pavlov, and so what does Locke say, and then what does Pavlov say?
So Locke thinks that like the mental operations are all in this realm of ideas, and ideas are like impressions on us from the environment, but it seems like Weiner's saying that Locke's view is kind of, I mean, he doesn't really give a view. There's like Weiner says, there's not like a mechanism proposed, but maybe the mechanism would have to be something like cognition is symbol manipulation. It's like this abstract process that's definitely computational. And I think, I forget exactly how he contrasts that with Pavlov, but Pavlov's view is much more, he pays a lot more attention to the connection between the organism and the environment and the context. And I don't remember exactly what Weiner says, but
it's a very interesting transition that he's setting up here. I think because I don't know if he goes into Pavlov here, or yeah, he gets to it, but before he gets to Pavlov, he says he talks about Locke, and then he kind of gives this context thing here, and there's sort of a release to describe a certain mechanism in Locke stuff. His theory can only bear bear the sort of relation to reality that a picture of a locomotive bears to a working locomotive. So he's kind of doing, he may be bringing up, map versus territory, and maybe sort of what does it take to draw the likeness versus understand the components of it. It's a diagram without any working parts. This is not remarkable when considering the data Locke's theory. It was in astronomy and not in engineering or psychology that the dynamic point of view, the point of view of working parts, first reaches importance, and that this was at the hands of Newton, who was not a predecessor of Locke, but a contemporary. So he seems to be making quite a very big history of like science, physics, whatever. Note that, and I don't know how to really substantiate or like, is it fair to say that no, but like only after this point of the dynamic point of view, only then could that have been like put into, would that have been incorporated into like other theories after that point? And he's saying this was a not, Locke didn't come after Newton, but they were in the same general area.
What is the point of view of working parts? Is this like where you have parts that come into association, or that's the whole point of the system, that it's working parts? Or I think he mentions this above, the mechanism by which, go back up a little bit. Yeah, the mechanism by which the ideas stick together lies in the ideas themselves. But there is, throughout Locke's writing, a singular unwillingness to describe such a mechanism. So the sort of the ideas are together because the ideas, like, it's in the context of the ideas, or
I'm kind of interpreting this. I'm kind of phone a friend for Amanda to step in. I'm interpreting this mostly as in he like Locke is essentially, it's almost like Locke is sort of trying to carve from a singular marble, sculpt an idea and say, okay, here is this stuff that goes together. There's not really there's not really an inquiry into the black box, if you will. And it's I think Norbert, rightly or wrongly, I think his argument appears to be, and I think I think I'm going to get to this next page basically to flesh this out. But he's saying, like, there wasn't really the zeitgeist, at least the preceding one, like how people were talking about things and for the history. There was not the dynamic point of view of working parts. They were just things that worked. There was ether, there was demons or something. There was the the it wasn't like a mechanics that was I guess I could say discrete, but like that there were actually a bunch of different moving parts, if you will. But instead of just there was a thing. I don't know if that's true, but that's my gist of it. Or that's my gist of what he's kind of trying to juxtapose to. And it looks like
Yeah, it's almost like an emergent system, like you just say. There are these ideas that come into association. They have an affinity. We can just only group those things as complex ideas. We can't necessarily go back and reverse engineer them. So it's almost like he's arguing for like kind of an early version of emergence, except to say he doesn't really use the same sort of explanatory framework, nor does he really kind of get at this idea of reductionism versus like non-reductionism. So I mean, those are all things that are just aside from that. But what he's arguing is that the mind is ideas. The ideas form complex ideas. It's almost like a network, associative network, where things kind of fit together, but we can't really figure out how they get put together in a certain order, which is not. I mean, I think we can do that to some extent. Not, I mean, we understand it a little bit differently, so it's not the same thing.
Yeah, and I would say even maybe less broadly on his end. He's saying like literally just that wasn't what people in the science or philosophy maybe as it was then, like they I guess Norbert's saying the focus was on classifying and not on investigating the function. There was no functional mechanistic attempts, or at least I don't know. I don't really know if that's true, but apparently that's what his argument is here. Yeah, and he's talking about biology, and Linnaeus did a lot of classification. One of my friends often refers to me as Linnaeus, but about map making, which is kind of funny here because I feel like I feel like Linnaeus is being used to be a representative of people who aren't like a reverse way of what I've been called.
They're just merely classifiers, basically.
Right.
Yeah.
Right. Linnaeus as a classifier, but also I guess they were saying frontiers with intellect too. Much under the compulsion to seize and occupy new territory, to be very precise and treated after the frontiersman becomes operative farmer and the naturalist and the modern scientist. So I guess he's saying there's, I think and kind of Jesse's language, Norbert's creating sympathy for why the initial steps were classification and not mechanistic there. Because he's saying only after further development and identification of the kind of classical forms or the little ideas, the discrete simple ideas, as my dad would say in his lineage of thought, could these come along. And we're getting back into Pavlov and what's up, where it's like, or also like I don't know if you took some notes here, man. I don't know if you want to say anything about them before we keep going.
Um, yeah, I think so. The question of like how Locke's ideas are supposed to fit together. I think the point is that Locke wasn't. It didn't feel the pressure from the intellectual norms at the time to even give that kind of explanation. It didn't, and yeah, I don't know how correct Weiner is here, but that kind of explanation wasn't a goal of science until Newton. Um, like a mechanistic explanation that appeals to moving parts. Um, yeah, so Locke like wasn't even concerned with that kind of thing. That was my impression.
I have a feeling that people did, so to say, give a damn about function at some point, but I do think I wouldn't be surprised, and I have no context. I would be curious to talk to like an actual historian who was aware. I'm getting the sense like, yeah, like the cool thing to do at the time would be, it wasn't really on the map, kind of, which is the funny way to say it. Like it was kind of like, yeah, we would let me just grab and demarcate these ideas, and then, excuse me. um, Pavlov more recently, in I guess late the quarter of the last century and the first quarter of the present one. So 1870s to 1920s, I think is what he's referring to. Covered his own way essentially the same ground Locke covered earlier. His study of the characteristics, however, progressed experimentally and not theoretically as Locke's had. So getting more into this implementation and function discussion. Moreover, he treated it as it appears among the lower animals rather than appears in man. The lower animals cannot speak in language. Conspicuous behavior is more emotion, food, body based. So as with food that Pavlov began with the physical symptom of salvation. It's easy to insert a cannula into the salivary duct of a dog and observe the secretion that's stimulated by the presence of food. And where is he going with this? He's basically going to past association. Here we have on the level of Emil reflects something analogous to Locke's association of ideas, which I feel like is actually a really broad concept that we're probably not addressing right. Like I don't know what Locke's association of ideas means.
Well, just what we talked about with ideas being sort of put together into complex ideas and having that associative mass of things. But I don't, yeah, animal reflexes, I wonder how that relates to that, though.
Yeah, I see what he's getting at, because it's just like there is an association happening in both cases, in Locke's theory and in Pavlov's. But an important difference is that Locke's is supposed to all the operations are supposed to be excuse me at the level of ideas, abstract.
Okay.
Then for the dogs and the food, it's specifically because of their like moments in time and context in the physical world. That's what causes the association. It's not in virtue of the ideas. It's not. I forget exactly what Weiner says when describing Locke, but it's not just because of features of the ideas themselves. It's because of the environment and the history of the animal.
That's a good point. Kind of bringing out like Pavlov was interested in something that the stimuli were basically the environment. So the stimulus would be delivered, you deliver an associative stimulus. So it's like if you had a bell and you had a piece of food and you had a dog that would respond to the bell and know that there was food there because they'd associate the bell with food. that's an association, and that's definitely, I think, fundamentally different from what Locke was talking about. But maybe not, because you're just basically dealing with this association. Ultimately, this has to be made in like a mind or a brain, and so they're not specifying that part of it. They're just saying this is a behavioral thing that's being, it's like in a black box to them, and then there's an output.
I had an interesting tangent, and I don't know how I feel about this because it's incomplete. But basically, it's almost. I wonder, and I don't know if this is where it's going or not because I don't remember or I didn't read the very end of it. I have no context. I feel a little bit empty brained right now, to be honest. But it seems kind of like a big stretch in some ways, like this thing that Norbert's trying to say. Okay, there's something between these two things you need to know, and if we keep this in terms of like his theory of learning, it's almost like there's a particular case. I don't know if embodiment is too strong of a word, but it's like he's kind of saying Locke's ideas are embodied in the context of the idea, whereas Pavlov is getting to an actual sort of biological, experimental interaction that's happening between like the past and the present and different operants and different memories and different sensors of the body. And because this bit about let us notice the rather complicated nature of the antecedents which are needed to produce the conditioned reflex of the Pavlov type. And maybe he's saying there's something, if it's, I don't know if it's quite a nod towards embodiment, but like there's a more robust embodiment because this is a living being, perhaps. And food and stuff like that. But I guess it goes. I don't know about this the cow. I'm gonna just write my note about.
Yeah, I wonder how he would. Actually, I would really do wonder how embodiment would come into this. But yeah, there are a lot of interesting relationships here. I don't know if it's like. I guess it is like like a good set of. I mean, I don't know if one influenced the other, but like, it seems like they're kind of hitting on similar things here.
So yeah, and this I'm glad we went back and kind of took this look because there's a whole bunch of stuff here, and I have a feeling we're not really going to get it. But like, I don't think Norbert's like, oh yeah, I'm totally for embodiment, but I feel like there's a weird dovetail here that could be there. And then this next paragraph is super. This is like the entire page, and I don't remember it at all. Cattle farms, wire fences, shocks. Such a fence may have to resist the pressure of the steers. Um, the original reflex is pain. The triggers inside of the, and then they're remembering that the transfer is triggered on the side of the fence. There are other triggers. It will be using anthropomorphic language to call these emotions or situations, but there's no such anthropomorphism needed to describe them as situations which generally carry an emphasis and importance not belonging to many other animal experiences. Such experiences, we may call them emotional or not, produce strong reflexes. So I guess he's trying to get, there can be certain associations that are severe and they generate strong reflexes. And it's saying in the formation of these conditioned reflexes in general, the reflex response is transferred to one of these trigger situations. The situation is one which frequently occurs concurrently with the original trigger. The change in the stimulus for which the given response takes place must have some such nervous correlate as the opening of the synaptic pathway leading to blah, 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 and thus constitutes what cybernetics calls a change in behavior.
That's an interesting thing. So actually, it's on two things here. First is a correlate. So this is something we used to worry about. we try to find the neural correlates of something. So if you have a behavior, it could be a disease state, it could be just like a behavior. We want to see what's going on in the brain, what's associated with it in the brain. So if I have like a behavior like an attention, like I switch my attention to one location to another, there's a shift in attention. I want to know what the neural correlate is, and I could do this with, say, like fMRI or EEG. You get a signal, and you can kind of figure out with enough experimentation what those correlates are. And then if you look up neural correlates in the literature, there are a lot of proposed correlates, which are just basically correlations. They're not strong statistical statements. They're just like what happens when I do this. If I can look into the brain and see what's happening at that time, and it would be like if I looked at like an engine, steam engine. I see the locomotive moving, the steam being generated. If you could look into the engine, what is it doing to generate that? And so that's like, but it's a correlate because unless I know how it works, it's like I just were completely ignorant of how it worked, and I looked at the engine in real time, I could tell you what it's doing, the function, but I couldn't necessarily, for 100% sure, tell you that that's the mechanism. Okay, so that's the first thing, is the correlates. Then the second thing is this change in taping. So we talked about like the Church-Turing thesis and the tape, which is a little bit different from this. Although I wonder like why they use taping in this context. It's just kind of like, what they're talking about is like, if you have a change in the stimulus, it changes the neural response or the neural correlate, so that there are different pathways that are opened up or closed. And so that has a lot of consequences for behavior. So you have this something in the black box of the brain that is like being adjusted or being changed. And so this is, I guess, a change in taping in this case could be just kind of a change in, like, if you replay the tape of history or of evolution, it's like going over time and going back in time and looking at a new scenario. And, so you have this tape of time, and you can look at it at different points in time and say, this is what happened. I can replay the tape, change things to see what happens. It's like simulation, basically, simulating the outcome. It's a change in taping is interesting in this sense because it actually refers to like a tape where things are recorded in time. So looks like you're going ahead and kind of getting into this part.
We're pretty much out of time, and I feel like I feel like I really want to understand all this better, because what I want to basically go back and listen to what you said like 2 or 3 times, because I get the neural part a little bit, and then I don't really understand what cybernetics changing taping means fully yet. I kind of get it, and then what he's doing with that next is like, okay, like I think this is the language stuff that I know. I don't have language for, but know like I thought about these things before, and I know what I think about them, but I don't have the connection yet, and I just feel like I would love to break this down. I know we didn't get at all in the chapter 4, and like this, I don't know if because I was late, but this hour went by way too fast for me. So we're kind of out of time. I don't know how much more in this chapter we have. Okay, there's like 1, 2. There's 3 pages left. I would like to really break this down, think about this, and talk about this. Maybe we can do a Saturday if we don't want to delay things. But like, I really want to know exactly what everything means here, myself anyway.
Yeah.
I want to understand what he's getting at. I think it's more important. Now we get to the 2 main concern messages too, which.
Well, I think if we talk about different types of computation on Saturday, that this could come in pretty easily.
Yeah, I think it could be part of the conversation.
Okay. I mean, I think I'm the person who's like ready at the least, or at least familiar with it.
So Amanda, do you have any readings that you would like to include in the? I mean, you can have them yourself, but I just didn't know if you wanted to contribute some things to that conversation.
On Saturday?
The first thing to come to mind is like Maley. I forget his first name.
Corey Mealy.
Corey Maley. On analog computation and analog versus digital. He gives an argument that there's a difference. It's not like one-to-one analog equals continuous, digital equals discrete. It's more nuanced than that. And that's the thing that comes to mind when I hear like talking about different types of computation. I guess I don't have anything specific that comes to mind about like physical computation. I'm looking forward to hearing more about that.
Yeah, we're just going to review. There's an article, actually, it was written by Corey Maley and another person on physical computation, just kind of like what they mean by that versus like typical church turn computation. So it's, it's just basically sussing out some of that. But I think it's also important. I mean, this would come into play a lot of the stuff here because, in cybernetics, they kind of talk about computation kind of front and center, and it's like, what do you mean by computation? Is it like just the computation of like the analogies to the brain and like digital computer, or is it more than that? And then we can say, well, cybernetics can be extended, or maybe not, to these other areas. Because like in biology, people often use computation, and they say, the brain is a computer, and then you could ask, well, what kind of computer is it? Is it a digital computer or some other type of computer? They're analog computers, they're mechanical computers, that sort of stuff. So it's not as if like, we're very clear on what we exactly mean by a computer. So that's one of the reasons I kind of wanted to get into this.
Yeah, and like I'm really curious about all this like these computations of physical computing, and then kind of how Norbert is kind of how he talks about at the time, like what we're calling in cybernetics, like kind of his what is he differentiating cybernetics differently from computing versus like some other things we might be more familiar with, and like that's on my mind also. Okay, any other closing thoughts before we
I don't think so.
keep this one be for now? Somehow there's always more questions whenever we complete something, but it's fun, so I appreciate it, and I guess that's fun because Saturday, well, I'll see Bradley tomorrow. Hopefully we'll be all. Do you think will you be around Saturday, Amanda, or do you have to like leave early? I forget.
I should be around Saturday.
Okay, good. All right. Well, we'll talk then, and I guess I'll say good night for now.
Right. Take care.
Yeah, talk to you soon.
You see. Bye.